Now we're going to start taking a look at 3 examples to illustrate this point, and just try and hammer home the concept a little bit further. Okay, so in our first example, we have an equation that's written in standard form, and that is y is equal to x squared minus 6x minus 16. So this is standard form of the equation, and the beautiful thing about standard form is that it tells us in the equation what the y-intercept is going to be, and in this case, the y-intercept is equal to the c value. So for number 1, when it says identify the y-intercept is at negative 16. So we can actually graph that just very quickly. We can plot that right here. So we know that the y-intercept is going to be here at 0, negative 16. The second part says factor the right-hand side of the equation. So the right-hand side is x squared minus 6x minus 16. And so what I'm going to do is I'm going to just quickly correct that so that it's a little more legible. Okay, and so in this instance, I'm looking for 2 numbers that are going to multiply to negative 16, but are going to add to negative 6. So if I go through and I'm looking for this, 1 and negative 16 will give me negative 16, but that adds to negative 15. 2 and negative 8 multiply to negative 16, and when I add those things together, I get negative 6. So the right-hand side, using factors to x plus 2 and x minus 8. Okay, so now that I've factored my right-hand side, I can go through and I can try to identify what the zeros are. So if my factored form is x plus 2, well, what number plus 2 gives me 0? Negative 2. And x minus 8, well, what number minus 8 gives me 0? Positive 8. Again, the opposite numbers that are in there. So now what I'm going to do is I'm going to determine what the axis of symmetry is. So the axis of symmetry is the average distance between the 2 zeros. So my 2 zeros are negative 2 and positive 8. So I'm going to do negative 2 plus 8 divided by 2. So that's going to give me 6 over 2, which is going to give me 3. So my equation for the axis of symmetry is going to be x is equal to 3. Okay? And so then I can quickly add that into the information that I have on this graph. I know that my zeros are at negative 2. So here's negative 2. And the other 0 is at positive 8. So here's positive 8. And I also know that my equation of the axis of symmetry is at positive 3. So here's positive 3 right here. So I'm just going to quickly draw in my axis of symmetry. That's my AoS. Okay. So the next thing I want to figure out in part 5 there says determine the y-coordinate of the vertex. So if I'm going to determine the y-coordinate of the vertex, I need the original equation. And so if you'll bear with me, the original equation is x squared minus 6x minus 16. So x squared minus 6x minus 16. I know that x already equals 3 because I determined that. So I'm going to substitute that piece in. So I'm going to put in 3 squared minus 6 times 3 minus 16. Okay, and so this is going to give me 9. Negative 6 times positive 3 gives me negative 18. And then again another negative 16. So if I quickly add those things together, it gives me 9 minus 18 minus 16 should give me negative 25. So that tells me that my y value is going to be negative 25 when the x value is 3. So my coordinates for the vertex are actually 3, negative 25. Okay. So now I know what my coordinates for the vertex are. So I know that it's going to be 3, negative 25. So here's negative 24, Negative 26, so negative 25 is going to be right about there. Okay, and so now I can do a rough drawing of the actual parabola. Okay, just based on the numbers that I already have. So I'm going to be up like that, and then up like that. Okay, so that just gives me a rough sketch of the actual parabola. Okay, so let's take a look at the next example. I don't have to graph either one of these, so it'll save at least a little bit of time. But the first example here says find the axis of symmetry and the vertex for each. So let's work quickly to figure out the axis of symmetry for both. We'll start off with the example that's on the left-hand side. So we've got this equation, y is equal to x minus 5 times x plus 1. So we can figure out the zeros straight away. The zeros for this one are going to be positive 5 and negative 1. So now if I want to figure out what the axis of symmetry is, I need to take 5 plus negative 1 divided by 2. That's going to give me 4 over 2, which is going to give me 2. So my axis of symmetry is when x is equal to 2. So now, if I want to figure out what the vertex is, so the vertex is going to, I need to figure out what the y coordinate is before I can figure out what the vertex is. I know that x is equal to negative 2, so I'm going to actually use my original equation. I've got x minus 5 times x plus 1. I can substitute in my values for x into the equation. So that tells me 2 minus 5 times 2 plus 1. So according to the rules of Bedmans, I can simplify things that are in brackets first. So 2 minus 5 is going to give me negative 3, and that's going to be multiplied by positive 3. So y is actually going to equal negative 9. So that tells me that my vertex is going to happen at 2, negative 9. Okay, so the x-coordinate is 2, the y-coordinate is negative 9. So let's take a look here at the next example, a little higher up on the board. There we go. And so in this one, again, we have an equation. And what we need to do is obviously figure out, well, what are the zeros first? So let's determine the zeros. So it's already written for us in factored form. So our zeros are going to be positive 4 and 0. So if we want to figure out what the axis of symmetry is, we take the average of those two numbers. So we add those two numbers together and divide by 2. So 4 plus 0 divided by 2 is equal to 4 divided by 2 is equal to 2. So the axis of symmetry happens when x is equal to 2. So now we're going to figure out the vertex. Okay, and so we can determine the vertex by taking the original equation. So the original equation is y is equal to 2 times x minus 4 times x plus 0. And I'm going to substitute in my found value of x, which is 2, into the equation. So y is equal to 2 times 2 minus 4 times 2 plus 0. So I'm going to collect all my like terms that are in the brackets. So 2 minus 4 is negative 2, and 2 plus 0 is still 2. So 2 times negative 2 is negative 4. Negative 4 times 2 gives me negative 8. So I now have an x-coordinate and a y-coordinate. And in this case, my vertex is at point 2, negative 8. Okay? So that's just an example of how you can use algebra to determine what the vertex of an equation is, of a parabola is, if you're given the equation of of a parabola.